Thanks everyone for coming. Just wanted to introduce ourselves. My name is Window Snyder, and I am the Chief Security something or other for Mozilla. I work on security strategy and help the engineering team develop security processes and work on mitigations for security issues and help make the product stronger.
I'm Mike Shaver. I'm one of the founders of the Mozilla project, and they still let me muddle with things. I work in various areas of developer support, helping make people more successful on the web, and especially with our products. And you'll hear more about some of the ways we're doing that today.
So what we want to talk about today is let you know who we are. How many of you guys have heard of Mozilla or Firefox? Okay, awesome. So let you know who we are and talk about the security process that we use. It's a process that's being used by a product that's deployed to like 100 million people. Tell you a little bit about the way we measure success, and talk about some of the features coming up in Firefox 3 and future versions of Firefox. And then, of course, talk about the program that we're announcing today, which is a program to share tools, and introduce you to the first of these tools, the JavaScript fuzzer.
So be real quick here. I think many of you, as evidenced by the show of hands, have heard of us before. We're a lot of things to an increasingly large number of people. We're best known for making the Firefox web browser, but I think long term we'd like to be known for having made the web a better place. So that's really what we work on in our products and in advocacy and in sharing our story with people like you, even early in the morning. The hangover session, I was thinking of calling this. Most of what we're going to talk about today is about how we put things together to make Firefox as secure as we can. So who are we doing that for? We're doing that for, as of April, about 18% of the internet users worldwide. 100 million people have chosen, virtually all of them have gone out of their way to get Firefox to use as their browser. In Europe, we're especially strong, almost 25%, probably a little north of that by today. The inexorable uptick for us in Europe has been excellent, especially in Finland. Is there any Finns in the crowd? We really love you a lot, and 41%, that's a really wonderful thing for us to see. So as our user base grows and as our market share grows, our responsibility to our users obviously increases with that. And so we take our role as producers of an agent for users on the web, a tool that's got to protect them and make them productive, very seriously. We also have some farther afield users. We haven't got good localizations for them yet, and the stats are notoriously unreliable, but we're glad to see that message is spreading there as well.
So I want to talk to you about how we work on making the product more secure at Mozilla, and hopefully demonstrate ways that you can use these methods in your own environment. So at Mozilla, everything we do is open source. It's open and transparent. Everything's out in the open. We couldn't hide it even if we wanted to, but we think of it as an opportunity, really, to help make our processes better and leverage the knowledge of the community, you guys, to improve our processes and make the application stronger. The different ways people engage with Mozilla to help us include testing in the design phase, code review. One of the things that's really special about this project is because everything is out in the open, developer documentation is available, the source code is available. People can really use this to participate in a different way than you can with traditional vendors. With a traditional security, with a regular software vendor, closed source, proprietary, whatever, you get to participate once they ship the product, identify security vulnerabilities in the product, hopefully report them back to the vendor, and then the vendor ideally ships a patch at some point. But with Mozilla, you can really participate, all along the development process. You can participate in the design meetings. Our meetings are all open to everybody. You can call in and participate with the all hands in the meetings and follow along as to what's going on in development. You can participate in implementation, in code review. People have developed tools to run against our source code, do penetration testing, and then, of course, in the traditional manner, once we ship something, identify a vulnerability, report it to us, and we'll ship a patch. One of the great things about this is that you get to spend your time in analysis and not trying to reverse engineer a proprietary format or file format or a protocol. Everything's out there, and if you email a developer because you have a question, they'll probably respond back to you because we want more help. We want to be able to help you guys join the project.
The openness there from the meetings has got us a lot of help from areas that people might find somewhat unexpected. One of the interesting things that happened when we first started to have our weekly meetings open and we finally got a 1-800 number set up so people could call in from all over the world, we discovered, in fact, that people from Microsoft have been calling in and listening and keeping up to date on what we're doing there. And it turns out they take great notes. We saw a document of them circulated around. So if the person who did that's in the room, that's awesome. If you want to keep taking those notes, we have a wiki to put them on. It would be much appreciated.
Thank you. And one of the things that we started doing recently is trying to give real-time updates on vulnerabilities. When a vulnerability is identified, we see a lot of information out there in the community as people are trying to identify what's going on and what the overall extent is to the vulnerability. And there's a lot of discussion about it, and that's all great and healthy. We want to make sure that our users have an opportunity to understand what's going on as we know it. So we try to post the information as we have it, as it's available, and blog about it. But of course, as we have more information, things change. So it's kind of a process that we're trying to refine, giving the information, but also with the understanding that, as we find new things out, this information might change. So the security group's about 85 people. We have a consideration between being as open as possible, but not making the details of a security vulnerability available before we have a chance to patch it, because we don't want to put users at risk unnecessarily. So the compromise we've come up with is the security group, which is about 85 people, and they're representative of all different areas of the community. These are people from different vendors. These are individual contributors like you guys. This is some of the members of the Mozilla Corporation. There's about 85 people. The list is posted. We think it's a great way of getting feedback from the community without broadcasting to the entire world the details that an attacker can use to make our users vulnerable. So the security group reviews security bugs. They help us write fixes. They participate in the discussions about how to fix a particular issue. They help us design with security in mind as we're going through the process of developing new features.
One of the things that the security group also helps us with a lot is making sure that we're well connected to other members of the security community, whether that's the CVE group, making sure that we have the right IDs up for vulnerabilities that we report, that people who are distributing our software, like Linux vendors and so forth, know what's coming down the pipe in time, that they're able to adapt to that. And also to help us administer a program we've had since, in fact, we were still part of Netscape, which is our bug bounty program, where we pay cash money on the barrelhead for people reporting security bugs in our product to us. We're not buying silence. The reporter of the bug has that information. We have no leverage over them to keep them from going public, and people have after collecting, or even some cases before collecting the bounty. But that's something that we want to incent people to report stuff to us, because we believe the sooner we know, the sooner our users can be safe.
But we don't think of it as paying for vulnerabilities. We think of it as like a thank you. So the other thing that's really just different about our process from a traditional proprietary vendor is that security testing is continuous throughout our development process, and you get the benefit of that work every 6 to 8 weeks in our security updates. The security updates you see from most vendors are actually vulnerabilities that are found externally and are shipped through the security update vehicle. Vulnerabilities that are identified through the QA process or by engaging security consultants to come in and do security updates are usually shipped through either service packs or in major updates. And the reason for that is that you get the benefit of a full test pass. But the problem with that is that you have to wait for a long time to get the benefit of that work. So we have built into our schedule this security updates every 6 to 8 weeks, and it's not just for vulnerabilities reported externally. It's also for our internal work that applies to security analysis. We do threat modeling on our system, on our products. We just went through threat modeling that we did as part of the process for Firefox 3. Engaged security vendors to come in and help us with that. For those of you who aren't familiar with threat modeling, it's a methodology for analyzing security software for security strengths and weaknesses by identifying entry points into the system and tracing data flows to the system. One of the benefits of threat modeling is that it allows you to identify the areas of highest risk and focus your penetration testing efforts and source code analysis on those areas of highest risk. Component security review, we're actually starting that process right now. We believe that every feature has a security impact on the overall product, and so we need to look at every single feature and identify how this feature impacts the overall security architecture of the product. And sometimes these things can, not necessarily be obvious. As you introduce new features, they introduce new entry points into the system. So we need to evaluate if they're introducing new vectors into the system and whether or not we've got mitigations for those potential new issues. And also use this process to identify whether or not our mitigations are going to be enough to protect users from potential vulnerabilities. And then develop test cases to analyze whether or not we're doing reasonable things in terms of our mitigations. We also do code review. And like I said, how do you do code review on millions and millions of lines of code, especially if you're starting with a new processor, you're looking for new things. You've identified a new code construct that results in a security vulnerability. So how do you go back over those millions and millions of lines of code and do code review on it? Well, that's very difficult. And so the place to start is with the areas of highest risk. How did you identify them? Hopefully through threat modeling. You can start with these areas and work backwards from the areas of highest risk to areas that are lower risk. So things that are highest risk include things like input validation mechanisms, anything that's handling user input directly, anything that's doing a lot of complex arithmetic or memory management, and any place where you're doing parsing. And of course, we're looking for code constructs that potentially form vulnerabilities, but also things like uninitialized variables and memory allocation and those sorts of things. We're starting from a point where we've been doing code review, but over time we identified different ways that different code constructs that result in vulnerabilities. So once upon a time, we didn't necessarily spend a lot of time thinking about integer overflows, and at some point we identified, oh wow, there's a whole set of vulnerabilities that result from these. You have to go back and look for those kinds of things. And it's difficult to make this code review scale. So one of the things that's very helpful with this is to introduce a peer review system where people review the code that you're checking in as you're writing new code, so that you're able to develop a level of confidence in the code that's new. And over time, you can say that when you started this process, the code that you created after that point is at least at this level. And over time, you get through a major portion of your code because there's a reasonable amount of code churn, at least in our code base, and you're able to have an understanding about what set of code has what level of confidence you can have in what part of the code base, unless you are keeping all your legacy code around.
We don't recommend that practice. The Mozilla code review system we've had in place for basically the life of the project now, so it'll be 10 years next March, unbelievably. But we still remember when we introduced that, and it wasn't something that those engineers had always had in place. So many of us still certainly recall the difficulty getting people to understand that even for a little change, even for something that's obvious, you want to have review. And it's not just to catch additional errors, but also to increase the number of people in your organization or project that are familiar with a piece of code. When you find a vulnerability or you find a construct that's questionable, you want to have a large number of people who can help you analyze that stuff, who can help you fix it. You want to keep your bus factor high, right? If a key developer has an unfortunate public transit accident, you want to make sure that you can still maintain the integrity of key pieces of your system. And code review helps with that at least as much as it helps with identifying vulnerabilities earlier in the process.
I think we actually covered that. So one of the other things that we do is engage security consultants. A lot of environments don't have enough resources to go over to do security analysis on a very large code base, and it's great to augment your team at certain periods of time, especially when you're in the process of doing a major security review. But it's also important to get a new perspective in there. These people are out there working on a lot of different kinds of applications, so they're able to see what other development environments are doing and bring that knowledge back into your development environment. So even if your team is great, having a different perspective from another set of security experts